In this video, we're going to be wrapping up Chapter 5, kind of our basic probability chapter. And what we're going to be looking at in this video are counting rules. All right? So a lot of what we're doing with these probabilities, especially when we're looking at kind of the classical approach, is we're just needing to find out how many outcomes are in an event, how many outcomes are in a sample space, so on and so forth, to get these calculations done. Right, so what these counting rules are designed to do are to allow us to figure those out without having to actually look at all of the different possible outcomes. Right, we can just get some information, do some quick math, and we can get our answer. Right, some of these aren't going to be necessarily mind-blowing, right, but we're going to go through them anyways. All right, so the first one is what's known as the fundamental counting principle. This one you don't really, I don't know, maybe I shouldn't say that. I mean, I'll be honest, this one's pretty straightforward, so you know, it's not like it's going to be that hard to get. But the fundamental counting principle says that, let's say we've got two events, right? E1, right, which has N1 unique outcomes, all right, so, or N1 possible outcomes. And we also have E2, which has N2 possible outcomes. All right, if we want to know, all right, the number of ways that these events can occur in sequence, right, then we can do, let's see, actually, let me see if I can write something like that down with the space I have left. Well, that's not really how I wanted to write it, but that's okay. All right, so to find out the number of ways that these events happen in sequence or can happen in sequence, we can just do N1 times N2. All right, and this is expandable, so if we want to add more events, right, then we can do that as well. We would just continue to multiply the number of outcomes, right, for those events by each other. All right, so some really quick, simple examples of this. Let's say we were, gonna flip a coin 3 times and record heads or tails for each coin flip. All right, so that's kind of what we're looking at. So in this case, we have 3 events. All right, so we've got kind of E1, which is the first flip, right, which is going to have 2 outcomes. E2 obviously would be the second flip with, yet again, 2 outcomes, and you can probably guess where this is going, right? E3 is the third flip with 2 possible outcomes. So the number of ways that this event could happen would be 2 times 2 times 2, right? Which is going to give you 8. All right, 8 possible outcomes. All right. Again, it's a very simple example, but it does illustrate, right, how this works. All right, but we are going to do one more of these. All right, but that is kind of just that fundamental counting principle. The next one I took straight from your book because I quite liked it. Right, so you've got 5 books, 5 whole books, right, and you're going to place these books on a shelf. Right, and you want to know how many ways can you place these books on the shelf, right? So to find this out, we can use our fundamental counting principle. So we say, well, we've got the first shelf, second spot, I guess you would say, third, fourth, and fifth. All right, so when we go to put the first book in the first spot, we have 5 books to choose from. All right, so the number of possible outcomes is 5. When we go to the second spot on the shelf, all right, now we only have 4 books. The third we have 3, the fourth we have 2, and the fifth we have 1. All right, so to find out the number of ways that our books can be placed on this bookshelf, right, we just need to multiply 5 times 4 times 3 times 2 times 1. All right, the answer to this is 120. There are 120 ways to place 5 books on a bookcase, right, or a shelf. I thought about doing it with my books, but I have too many and I don't want to count them all. But that is how we can do that. All right. Now, another reason we did this example is because this is an example of something else. All right. So it's not just an example of the fundamental counting principle, but it's also an example of what's known as a factorial. A factorial, right, or for a factorial, so suppose n is a positive whole number. Right, if this is the case, then the factorial of n, which we notate as n in the generic form, n with an exclamation mark or just whatever number it is with an exclamation mark, right? The factorial of n is equal to n times n minus 1 times n minus 2 on until 3 times 2 times 1. All right, so a factorial is just whatever the number is, you multiply it by all of the other whole numbers that precede it until you get to 1. All right, one thing to note, by definition, the factorial of 0 equals 1. All right, that's going to be important later on, but we'll go ahead and state that. All right, but that's what a factorial is. So in that last example of the fundamental counting principle, that is what we were looking at. We were looking at a factorial. We were looking at the factorial of 5. All right, so the factorial of 5 would be 5 times 4 times 3 times 2 times 1, and it would equal 120. So this is a function that we're going to be using as we go along in different scenarios. Right? So we'll talk a little bit more about it in just a second, though. All right, about kind of how to use it, I should say. It's pretty straightforward. I mean, you could do it on your own, but there are going to be some cases where you don't want to. But before we talk about that, let's talk about what are known as combinations, or a combination. So the number of combinations of n unique objects taken k at a time is, didn't really leave myself that much space, but that's okay. All right, so here is how we would, this is the formula for a combination. All right, so n unique objects taken k at a time. All right, we can find that by taking the factorial of n and dividing it by the factorial of n minus k times the factorial of k. All right, so that's how we would find a combination. All right, so when might we use this? All right, well, let's suppose I asked you guys to tell me how many unique hands you could have, right? How many kind of unique 5-card hands you could have from a deck of cards. All right, so how many different combinations of playing cards, right, can you make if there are 5 of them, right? 5 that if you're getting 5 cards, right? Now this is a great example of why we want things like this combinations function, all right, and why we want these counting rules in general. All right, but let's go ahead and work through this. All right, so setting this up. All right, so n is the number of unique objects for a deck of playing cards. That is the cards themselves. So there are 52 unique objects. All right, so 52 c, and then k would be the number of how many you're taking at a time. In this case, it's 5. So we have factorial of 52 divided by the factorial of 52 minus 5 times the factorial of 5. All right, so we're going to simplify this just a little bit. We're going to bring it to 52 factorial over 47 factorial times factorial of 5. Now, this is really, this would be a lot if we were doing this kind of by hand, right? Because we have to do 52 times 51 times 50 on and on until we got to 1, right? Nobody, I don't think anybody wants to do that, right? We've also got this 47, going to be a similar thing, very long process. We don't want to do that either. All right, there are a couple of things we can do. One, we can break this thing apart a little bit. I don't know if that's going to be enough room. I'll just move it over here. All right, so we can expand that factorial of 52 in our denominator, right? Because that's equal to 52 times 51 times 50 times 49 times 48 times the factorial of 47, right? Because that factorial of 47 is going to carry it the rest of the way. All right, then we've got in the numerator or the denominator 57 or 47 factorial times 5 factorial. Well, now that 47 factorial cancels out, right, and you've got something a lot more manageable. All right, we can actually pretty easily enter this into our calculator. This way we're only multiplying 5 numbers in the numerator, right, and I guess 5 in the denominator as well. All right, also, just because of the way we've done these notes, we also know that that's 120. All right, but regardless, this actually is not the way that you're really going to want to do it. All right, because that takes a really long time. All right, and if you have a scientific calculator, which you should for this course, all right, and if you don't already, then I would highly recommend you get one as soon as possible. All right, then you're going to have a factorial function and a combinations function on your calculator. All right, if you have a Texas Instruments like this, and we'll see how close I can get to this without messing it up. Not that close, okay. Anyways, so we won't worry about that. All right, but if you've got a Texas Instruments, you're gonna look for a button that says PRB. It's gonna be up here in kind of the top left corner-ish, all right? And when you open that, you're going to have three things. You're going to have an exclamation mark. You're going to have something that says NPR and one that says NCR. The exclamation mark, that's your factorial function. And the NCR is your combinations function. All right, don't worry about the NPR thing. We're not going to really use it in this class. All right, and no, we're not going to use it. I'll tell you that. All right, but when you have that function, all right, this becomes very easy. Essentially, all you do is you just need to enter the N, hit that PRB button, hit the NCR button, and then hit in your K. Hit enter and you're going to get your answer. Right? If you've got a Casio, I think it's a secondary function on one of your buttons near the number pad on your calculator. If you have like a graphing calculator, it's in a menu. You should be able to Google or YouTube to find out where that function or where those functions are in your calculator. All right, but when we do put this into the calculator, all right, do 52 PRB C and then hit the 5, right, and we hit enter, we're going to find that there are 2,598,960 unique 5-card hands. All right, so this is why we want these counting rules, right? Nobody wants to have to sit there and say, okay, King of Hearts, Queen of Hearts, so on. That's one set. Now let me change one. Let me change another one. You know, nobody wants to have to go through all of those different combinations. Right? It's much easier to do something like this. All right, but we will be using both these combinations and these factorials later on in the next chapter. All right, so we do want to get familiar with those. If we're having trouble finding those on our calculator, feel free to email me about those. I can't guarantee I will know where it is, especially over email, but I will try my best to help you figure that out. All right, but again, you should be able to just Google it, and it should tell you pretty quick. These are very common functions. People are going to know where they are if they use those calculators. All right, but that's it for this video and for this chapter. I will see you guys in the next chapter.